Okay, the next section of the text is the Bronstead-Lowery concept. So this is the second of three concepts for acids and bases, or three different types of acids and bases. This time the definition of an acid is pretty much the same thing. It's the species donating a proton, which from the Arrhenius definition, basically it had to have a proton or had to have an H plus to form H3O plus. So it's very much the same type of definition. The base now does not have to be a hydroxide. So this broadens the definition of what can be considered a base. So just to review, Arrhenius, it was found that the definition of the acid was that increased the concentration of hydronium, which is essentially the same thing, meaning the fact that it had to donate a proton or an H plus, whereas the base said that it had to increase the definition of a hydroxide. What's different this time is that, like I said, the acid definition is very similar. It donates a proton, which means it increases the H3O plus concentration. However, the base is now just something that accepts the proton in a proton transfer reaction. So in this figure down here, you see that this is a Bronstead-Lowery acid, and in fact it has an H plus A minus, so this is a generic form of writing an acid, HA, versus the base, okay? And so in this reaction, the Bronstead-Lowery has donated its hydrogen, so you can tell this pair because the A is the same, except for the fact it's an A minus now. It's just lost its hydrogen, and the base is the Bronstead-Lowery, and so it has accepted that hydrogen. And so this pairing of HA to A minus and this B to HB plus are called the conjugate acid-base pair. So in each pair there's one acid here and one base, and here's one acid and one base. So your reactants are always going to be just plain acid and base, and the products are going to be conjugate base and conjugate acid. So the word conjugate is only going to appear in the products. And then you have an amphoteric species, which is a species that can act as either an acid or a base. The most common of those is water. Water can act as either an acid or a base, and I'll show you some of that on the next one. So this is the most common amphoteric species. Okay? So in this reaction, they want you to label each species as an acid, a base, and then the conjugate acid and the conjugate base. So what I'm looking for, what I need to identify here is I'm looking for anything that's not the hydrogen. So the CO3 and the CO3. So in this case, I went from 1 H to 0 H's. So that means that this is my acid and this is my base. Okay? I could have started, let me go with the different color here. I could have started with NH3, so I'm looking for something that's not hydrogen, so it's N, okay? And here it is here, okay? This time I went from 3 hydrogens to 4 hydrogens. So when it gains a hydrogen, it is the base. I just realized I miswrote something here. Let me go ahead and correct this. I don't want to write the fact that this is just a base. I want to write this as being a conjugate base, because in the product side, you always include the word conjugate. And going back, I can't find my, there it is. So this one being a base, this is the conjugate acid. Okay, I highly suggest that you stop here and try to do these other two on your own before I go through them. Okay. So here we have, this one's the easy one to identify, here and here, okay? So if I look at this, I have 4 hydrogens on this side and 3 on this one. So this is 4, therefore this is my acid, therefore this must be my conjugate base. And you can write just C base if you want to. It just has to have something denoting conjugate. So that leaves my other one. So if I always have to have an acid and a base, so therefore this is the base, and therefore this must be the conjugate acid. And I can see, in fact, that I went from 2 hydrogens to 3 hydrogens, so the base gains the hydrogen as it goes. down here, this is the easy one to identify because it's pretty unique looking. It's here. So now I'm going to look. I went from 7 H's to 5 plus 3 is 8 H's. So therefore it gained a hydrogen, so therefore this is my base. This must be my conjugate. Like I said, I can just put C there, acid. That means that the other species must be my acid, and therefore this must be my conjugate base. Okay. Now I want to point out here, in this reaction water is the base, and this one it is the acid, and that is what basically the definition of an amphiprotic species is. Water can act as either a base or an acid. Okay. Going on. All right, this one says write the formula for the conjugate base formed from the acids. So if this is the acid, what is its conjugate base for this? Okay, the book has these in reverse order. If you go to the textbook and look at the problems at the end of the chapter, they do these type of problems before they do them in a reaction. It's easier for me to see it as a reaction first and then go to as an individual, so that's why I covered it this way. So an acid by definition donates a hydrogen, so I want to lose one hydrogen. So this is HPO4. Now when I'm doing this, an H is positively charged. So therefore this is a -1, so this becomes a -2. So it always becomes one more more negative when I'm going from the acid to the conjugate base. I'd stop here and do these on your own. Okay, so on this one it really doesn't matter. This one has 2 correct answers. It could be OOCCOOH, again, because it went from zero charge, it has to be negative. Or I can write it as HOOCCOO minus. This is the way that the answer was actually given on the worksheet that I found, but either answer is correct. We normally think of the acidic hydrogen as being the first one listed, so I can see that you would more likely to write this one. I'm not sure how the homework program is going to accept them, so you need to probably look at an explanation first. For this one, I only have 1 hydrogen, so it becomes CN. This was neutral or 0 charge, so it becomes a negative. This question is the opposite. Write the formula for the conjugate acids from each of the bases. So these 3 things are bases, and it wants to know what the acid is. So a base accepts a proton. So again, H is positive, so this time it's going to become less negative or more positive. So if I add a hydrogen to this, it just becomes HF. This was a -1, so it becomes neutral. I would stop here and do the rest of these on your own. Okay, this is going to go from 2 hydrogens, so to add a hydrogen would become 3 hydrogens. It becomes H3O+. In this one, you could technically write H in H3, and if I was grading the test right now, you could do that. However, if you're doing it online, it's probably going to want it as NH4+ on this one. Okay, so that's the end of this section.